Yes, hello from Romania. I worked again like a slave for this project that we see here. Right now it's not powered on. Let me power it on, and it's exactly 5 volts there. And right now it's not working. It's not engaged, but I can do this. It's starting up, and this is not that big and is moving around. I have to is pivoting in this point. So yes, before this big board that you see here. I was having this board, which worked. It did its job, but not really. I mean, it was working on its maximum, not in between 0 and 5 volts. So not at 3, not at 4, not at 2 volts, or whatever voltage I was selecting from this potentiometer here. It was very fast and easy to build. I had a shitty switch here that was doing exactly like the same thing as this switch is doing here. It was opening and closing the entire board. Well, the motor. But it was not doing actually the job. But this guy is actually doing the job. I did that circuit because it was fast to build. I built it in a day, or less than a day. I built this board also in a single day, but it's as you can see, it's very complicated. Well, not very, but complicated enough. And it wasn't easy to build. I stayed on it 1 day long, and even the next day, which is actually today. I finished it well half an hour or 1 hour ago, and is absolutely doing the job. If I'm switching it on right now, if I'm moving the potentiometer, unfortunately, you see, it's not closing to 0 volts. It's closing to something 0.5 probably, or less than 1 volt. And now I'm bringing it to the maximum. This is maximum, and also the brightness of this green LED is showing the voltage over the MOSFET. This is the MOSFET. It's a big scrapped from boards MOSFET. It didn't work with smaller MOSFETs like this one. So this kind of MOSFET didn't work. I tested it. This motor, I mean, this motor with that small MOSFET didn't work. That MOSFET got extremely hot, extremely quickly. But this guy, which is also a SMD component MOSFET, it doesn't getting hot. I have absolutely no idea what it is, what specification it has. The only specifications that I was interested in by testing, not by looking. I didn't search for this component online. I don't have its characteristics. I don't really care what it's saying there, and you cannot see shit also. The only characteristic that I was interested in, this is the circuit for this board that you see there. And the only characteristics, the only specifications that I was interested. So what the pins are: gate, drain, and source for this particular MOSFET, and not overheating itself when I'm bringing down the power, because right now we are variating the voltage. This is a PWM circuit. I used the 555 IC there. This is a diode. That's another diode. This is a potentiometer that I scrapped from a board some time ago. This is brand new switch. I have to keep my hand. This board requires 2 hands to be operated. When it's very stiff switch, but it's good. I really like it. It's brand new, this switch, and also this potentiometer is brand new. And yeah, that's it pretty much. It's doing the same job, but a little bit better right now, because right now I really have the possibility to seriously variate the voltage and the speed in the same time of this motor. Before it was variating, but it got some problems. So this is the correct circuit. It's as you can see, it's a lot more bigger, a lot more complicated. This is the circuit that I used. Make abstraction of that part. Yeah, it's a bit weird how I linked everything. This is my first circuit with a 555 PWM. Back then, in that project, I was driving this computer fan motor, and I was using a very small transistor. This guy. Actually, this is its actual name here. This worked for that type of motor. It worked very well. It's the same circuit for what I have here, exactly the same circuit that I have right now. Right now I'm using exclusively only 5 volts. Let me correct this. This is 5 volts, right? Okay. This is it. This is the circuit. This is how everything is linked. This is the circuit that I followed, and this is the circuit that I built. And this is actually the board. This is not the first one. This is a second board with PWM. As you can read there, PWM MOSFET driver with 555. Here is the 555 integrated circuit IC. This is the LED and the resistor. This is a diode. This is a connection to the motor. And this is a 10 kilo resistor to the base. This is a MOSFET, the transistor MOSFET. Originally, like I said, I put a very small transistor, like this guy. but then I had to switch it to this. And right now I'm using this guy, which is luckily enough I have the same position of the pins, one top and two on the corners in the same. And as you can see there, you see it's exactly like that. I link it, and I soldered this big pad to the pad that is underneath there. So I did it exactly like here, but with a bigger transistor. And here is a 10 microfarad capacitor here between the plus and minus. Here are two resistors of 4.7K. This is a capacitor here of 100 nanofarads. This is a diode D1 and D2. You can see it there. This guy D1 and D2. And here is another capacitor of 10 nanofarads. Potentiometer 1, potentiometer 2, and this guy here. I made a mistake here. I inversed everything. I thought this potentiometer was the speed variator, and it was this guy. And I had to switch and to find other potentiometers, different potentiometers, and proper ones. And this is how. Before it was looking. I was having a big one here and a smaller one here. So I had to resync everything, and yeah, I dragged some wires to that guy, and that's it. Problem solved. And this guy here actually is saying here, so frequency adjust and duty cycle adjust or speed for P2, for potentiometer 2. So this is what I said, frequency adjust is varying a little bit the frequency, which is interesting. It's fine tuning with that potentiometer there, the orange one. And yes, it's doing exactly the same thing as before. Nothing changed really from functionality perspective, but from the electronic side of things, this is an upgrade. So yeah, I'm really happy about this board that I got the courage to make it, because it was. Let me open it just a little bit, and now I can actually de-isolate the wires at a very low speed and not stopping the motor. Before, if I was lowering the speed with that driver circuit there, as you can see, I'm pressing lightly. Right now it's still stopping if I'm pressing too hard, but if I was lightly like this pressing with that circuit, it was stopping very quickly. It wasn't doing really a good job, that circuit. It was doing something, kind of a good job, but not really. It was medium, not bad, not good, but this is good. This is the good circuit, it's doing the good job, and it's the circuit that you want to build. It's a bit more complex. That's the positive thing about that circuit. It's very fast to build, and this one is very hard and slow to build. It's having a lot more components on it. Yes, I think I finished presenting the circuit diagram here. Yeah, pretty much this is it. What you see here is a 1:1 scale. It's exactly the same size as here. Exactly the same size. And I built it with little boards that I glued on a bigger board, cardboard actually. And I've added more stuff to it, like this permanent LED that is showing me that is in power, even if the motor is not working, like right now. It's pivoting everything when I'm switching here. So right now it's telling me it's powered, the board, even if it's not switched. The motor is not switched. And now when I'm switching the motor, I get that green indicator LED, which is having a double function. First of all, is by illuminating is telling me that the current is passing through that MOSFET. And also when I'm varying the speed, is also dimming in brightness. As you can see, this is full brightness and full speed also. So this is the double role of that LED. Very smart LED function that I imagine it. I hope you like it. I really hope you like it. I for sure I like it very much how it's looking and feeling right now. It's more professional. The feel of it is more professional when I'm working. When it's more stable. It's more very important detail. This potentiometer was switching very fast from 5 volts to 0 volts, like a millimeter. But here on this potentiometer, I have the entire full range from one side to the other side. From one maximum to the other maximum of the potentiometer, which is absolutely great. It's extremely linear, and I really like it. It's a very good circuit. This is the correct circuit. If you want to build something like this, you should do it like this with this PWM circuit with a 555 or whatever PWM you have. This was tremendous helpful for me. It helped me a ton. One other interesting characteristic that I don't have it. I have it here because I'm using it. I'm using this laboratory power supply here that is showing me the amperage. Right now is 60 milliampere drawing from this motor. Right now I'm lowered it, so it's almost closed, and it's like 10 or 20-ish, 15 probably milliampere drawing through some coils there. But when I'm switching it maximum, you see the milliamps are growing, are getting higher. This is the maximum. it depends of the rudiment of the bearing that I have here. If it's too much force on it, it will increase the amperage consumption. If it's loose, it will lower. So pretty much right now it's formidably good. 160 milliamps drawing instead of 200 milliamps, like it was. No, I think it was like that. Let's bring it down to 10 milliamps, somewhere around 10 now to minimum, now to maximum. Yeah, 200 milliamps. And then it's stabilizing, getting down for some reason. I'm not sure why. But this is the thing that I wanted. Now I'm bringing it slower. The thing is, yeah, it's very. I really like it. How smooth you can control it. I really want this amperage reading that we see there, an amperage reading display somewhere on this board, because it's extremely helpful. Is showing you the forces. Actually, the forces. Let me bring it up a little bit. So right now, let's say it's 100. Let's bring it to 100 milliamps. Okay. So now I'm pressing with my finger. And I'm kind of stopping it. And you will see how it's increasing. Not much, but it is increasing. And this fluctuation, you can see the forces that you apply on this axle, and the power is draining, and the forces actually that are soliciting this motor, and also the circuit. So this thing, I'm not sure if I can add it pretty in the near future. I'm not sure, maybe in the later future, but I'm not sure. But it will be a very good thing to have. It's extremely helpful to have such an indicator, numeric indicator like that here. That is telling me how much stress the axe of the motor, the coils of the motor are sustaining when I'm pressing. This is, of course, is a very small project, but I really like quality. You know, very good options to have, and readings. If you have very good readings in electronics, you are a very good electronist, a very good engineer. If you don't have very good readings, you are a shit electronist. So keep this in mind. Thank you very much for watching, and I hope you like it. Please leave a like. And tell me your thoughts if you have any, and goodbye, and see you later, alligator, on my next project.